Okay, so following my previous talk, I'll now present a collaborative work with Simon Greenhill at the University of Auckland, Aymeric HERMANN, who's of course in the room, many of you know, and Russell Gray at the Max Planck Institute for Evolutionary Anthropology. And this talk is focused on the outliers as a whole. So here for the first time, we've combined historical linguistics with computational methods taken from evolutionary biology, as well as archaeology, to better understand the history of the Polynesian outliers and their position in the Polynesian group. This is not simply responding to the issue of the outliers' relationship to the Eastern Polynesian peoples, but their relationship to one another and the directionality of the multiple migrations in the history of the Eastern Polynesians and the outliers. Importantly, what is presented here is a quantitative approach that applies the classic comparative method of historical linguistics using standardized and globally comparative data that is not cherry-picked. This allows us to objectively test theories discussed this morning already. So since the 18th century, the languages spoken in the Polynesian outlier populations have been recognized as relating to Polynesian languages. And in the last 75 years, based on linguistic evidence, we see that they clearly descend from Proto-Polynesian. We all know this. But apart from a clear Polynesian linguistic origin, the history of the Polynesian outliers remains ambiguous. Based on linguistic evidence, the outlier languages have been grouped in various ways since the 1960s. Providing some background to what has already been discussed this morning, Green and Polly both provided evidence for the outliers as part of a Samoic outlier group, which included the outliers and most of the languages of Western Polynesia, except for Tonga and Niue. They argued, They argued that Nuclear Polynesian divided into an Eastern Polynesian subgroup on one hand, and the Samoan outlier group on the other, which included Samoan, East Futunan, and as Andy Polly put it, probably all outliers. Polly further claimed that within Samoic outlier, there were at least three subgroups, one comprised of the two northwestern outliers, Nuku'oro and Kapingamarangi, a second consisting of what he called the central outliers, Sikayana, Taku, and Ontong Java, and a third consisting of the two Vanuatu outliers, Melifila and Futuna Aniwa. Another of the major hypotheses, shown here by Jeff Mark's 2000 tree, was that the outliers indeed form a nuclear Polynesian group, but that the more northern outliers, Samoa and the Eastern Polynesian languages, form a group called Ilician. Then more recently, as we've all been discussing already at some length, Pila Wilson has proposed that all outliers, except for those in Vanuatu and New Caledonia, group with Eastern Polynesian languages as shown here. So even in linguistics, the history of the outliers themselves is really not clear or agreed upon. So what my co-authors and I set out to do was combine these different methods from different disciplines to answer the following questions. How do the Polynesian outlier languages relate to one another and to other Polynesian languages? Did they expand westward in one major pulse or in multiple waves? When did this expansion take place? And where did the Polynesian outliers originate? So to answer these questions, we've combined classic historical comparative methods and Bayesian computational methods with dating from archaeology. The Bayesian analysis allows us to incorporate different kinds of signals, something we don't have in the classic tree model, which I hopefully expressed to you this morning. And things that are a model that's responsible sort of for the shared features that we find among the Eastern Polynesian languages and the Eastern Polynesian languages and other Polynesian languages. So what did we do? We combined about 200 basic vocabulary concepts from a total of 54 varieties of Central Pacific languages. The sources included primary data, unpublished legacy material, and published work like grammars and dictionaries. For some languages, multiple varieties were included, and even where they had more than one source available with differing data due to the time of collection, maybe end of the 19th century, and then more recently, we use both of these lists. We chose to focus on basic vocabulary for multiple reasons. First, as I said this morning, it's the part of the lexicon that is least likely to change. Second, it provides a set of linguistic features directly comparable in each language. And third, it provides a data set which is manageable for the Bayesian analysis. These data were entered into the Austronesian Basic Vocabulary Database, shown here with an example of Tahitian. Then, using the comparative method for historical linguistics, I coded these concepts in the Austronesian database for cognacy based on established sound correspondences and patterns of sound change. For example, what you see here for woman, all reflexes of Proto-Polynesian fafine got coded as 1, and then there's a little change in some of the central languages of East Polynesia, and all of those got coded as part of the fafine group, but with their special change, they were coded as 1, 2. So that way, all changes in sound and morphology can be accounted for. Additionally, and importantly, where a loan or borrowing was known and confirmed in the literature, or where a form was clearly analyzable as a borrowing, based on reported sound changes, entries were marked as loans and then were excluded from the analysis. Then my co-author Simon Greenhill performed his magic Bayesian phylogenetic analysis in order to generate a set of possible trees for this group of languages. This kind of analyses, for those who aren't familiar, take statistical models from evolutionary biology and apply them to languages to infer language histories based on presence or absence of a form in the sets of innovations that I described as being determined by the comparative method. And these provide a probabilistic framework for formulating and testing hypotheses regarding language change. So this particular analysis that we did generated 10,000 possible trees. This method also allows us to date divergence of language groups by setting a date at different points in the tree and allowing for varying rates of change on each branch of the tree. Here in this study, we set a date at the root of the tree, which corresponds with Proto-Central Pacific, and another at the start of the Proto-Eastern Polynesian branch. The archaeological equivalent to the start of the linguistic diversification of the Central Pacific languages is the earliest settlement in the Fiji Western Polynesia area. For the Proto-Eastern Polynesian branch, the equivalent is the earliest settlement in the Central East Polynesian area. For this, we used 81 dates from early Lapita sites in Fiji and Western Polynesia, and 65 dates from Central Polynesian archipelagos, and modeled these in a Bayesian framework, considering the stratigraphic order within each site. Without going too far into the technical details and allowing you to ask Aymeric questions in the question and answer session, but quickly, we use the Oxcal outlier model of Pechi and Kirch on the To'anga sequence, which makes it possible to assign different prior outlier probabilities for dates associated with identified short-lived species and for dates of non-identified charcoals. We use the lower boundary of each model to calibrate the tree, a 2 sigma interval of 3,251 to 2,927 BP for the initial Lapita settlement of Fiji, and a 2 sigma interval of 1,168 to 823 BP for the earliest settlement of Central Eastern Polynesia. And here are our results. So remember before that I said this analysis generates thousands of possible trees. So here in what we call a densa tree, we see all of those 10,000 trees on top of each other. And where we see the darker groups, this is where the most trees overlap. And we can more clearly see the groups that are more well supported. So here we see 6 main groups of outlier languages. The diversification of these 6 separate groups indicates already that there were multiple westward migratory events by the ancestral Polynesians. Had there been one migration, for example, we would expect the outliers to form a monophyletic group. Importantly, we also see a lot of uncertainty sort of higher up in these areas. And this shows up as web-like or cloudy. And these are areas where there are conflicting signals, that is to say, competing topologies. And this kind of uncertainty can represent high degrees of contact, go figure, undetermined loans, or multiple overlapping groups of innovations. For example, we see here Rotuman, of course not a Polynesian language, but Rotuman getting pulled in 2 different directions, which reflects what we know of its close interactions with Polynesian languages. Looking at the consensus or summary tree, which is a summary of all of our 10,000 trees with probabilities on each node, we see that we get high support for the 6 major outlier language groups, all above 65 and most above 70. Turning to some of the previous linguistic analyses, when we compare with those, we do see support for Andy Pauly's Melifila and Futuna Aniwa. We see support for a central outliers group and for the Nuku'oro Kapingamarangi group. We don't see support for Samoic outlier. We don't see support for Elysian. And most importantly to our conversations today, we do not see support for any direct history with Eastern Polynesian. Regarding timing, in applying the model dates from archaeology discussed before, we use the linguistic structure to infer a chronological order of the diversification process. So in the right panel here, we have the two age estimates for the Proto-Central Pacific route and the start of the Proto-Eastern Polynesian branch, and density estimates of the separation dates within each outlier group in the 10,000 trees generated by the phylogenetic analysis. Although these estimates do not correspond to a colonization event necessarily, they can be considered as a terminus antiquem for the settlement of each outlier group. We estimate that the multiple events of separation of the outliers were not strictly contemporaneous. And using the Proto-Eastern Polynesian fixed date to help our comparison, we see that there is a high probability that the Futuna Aniwa Melifila group began diversifying before the earliest settlement of EP, and that the other outlier groups diversified after that point in the first half of the last millennium. The two latest differentiations are Anuta Tikopia and Nuku'oro and Kapingamarangi, likely shown as much later here because these languages were in intense contact until very recently. These dates reflect the more distinctive separation of these languages from one another, and the tree then reflects this history of close contacts. So we've answered 3 of our 4 questions, and now for our last one. So using our constructed tree, my co-author Simon then ran phylogeographic analyses to look at the possible directions of the Polynesian expansion. And very quickly, I'll go through this. To do this, we mapped the locations of the languages onto our tree as a set of discrete locations. Then we enforced the known homeland for Proto-Polynesian in the West Polynesian area based on archaeological and linguistic evidence. We then took each tree and used a model to estimate the likelihood at each node. And then we used this model to simulate the location history across the whole sample of possible trees. Summarizing these simulated histories provides us with the most probable estimates for the number of transitions between each location. In this summary map of our results, the arrows are thicker where the number of changes is higher. Here we more clearly see that the Polynesian expansion included lots of movement. We see potentially multiple migrations into several areas, and the highest number of overall transitions into the outliers is from Western Polynesia. Looking to Eastern Polynesia, we also see that the highest number of transitions is from Western Polynesia, with a very light line from the Solomons indicating some input into this area in their early history. This supports the context scenario which I outlined this morning. So to summarize, in this study, we confirm that outlier languages form multiple individual groups distinct from other Polynesian languages. We show support for a complex migration scenario that shows at least 6 major outlier migrations from Western Polynesia, and we provide a model for dating the diversification of these groups. Furthermore, we show evidence of multiple migrations into the Eastern Polynesian area, primarily from Western Polynesia. We also see lots of uncertainty, which supports continuous interactions between the outlier populations themselves and with other parts of Polynesia. In conclusion, this study provides objective and quantitative support that the history of the Polynesians, again, cannot be viewed as strictly linear. Thank you again, and I will not be here anymore.